Hello friends, welcome back to my channel, and our today's theorem is the length of the tangents. That means we are given length of the tangents drawn from the external point. Now what does a tangent mean? Tangent means a line which touches the circle at one point. So for in this case, our tangent is PQ and another tangent is PR, where point of contact is Q and R, and the length of this tangent from the external point. Now, what is our external point in this case? Our P is an external point for this case. So, the circle tangent's length is equal. That means we need to prove that PQ is equals to PR. This was the statement. Now, let's start with the data. Data means the thing which is already given to us. So, what is already given to us? What you can see from the figure, that we are given a circle with center O, where P is an external point and PQ and PR are the tangent of the circle. So write that we are given circle with center O, and P is the external point, where PQ and PR are the tangents. So where PQ and PR are the tangents. Okay, are the tangents. You are done with the data. Now, next is to prove. That means the thing which we need to prove. As we have said earlier in the statement that the lengths of tangents are equal. That means we need to prove that PQ is equals to PR. So, for to prove, you will write PQ is equals to PR Now, next comes your to construct. What we are constructing? We are joining the line O with Q, O with R and O with P. So, to construct, you will write that construct and join. What we are joining? We are joining OQ, OR and OP. Okay, this much is for the theorem. Now let's start with our proof. Okay, so for the proof, as you can see over here clearly that OQ and OR is perpendicular. How we came to know that it's perpendicular? As we have seen earlier for this theorem, where it was clearly said when a radius touches a tangent, it forms perpendicular with the base. So from theorem 10.1, we know that the radius are perpendicular to the tangents. So you can write that OQ is perpendicular to QP and OR is perpendicular to PR. From where we got this knowledge? We already got this knowledge from theorem 10.1. So write here theorem 10.1 of the circle. So we know that this is triangle. Now for the congruence rule, we will take two triangles. Which two triangles we are considering? OPQ triangle and triangle OPR. So write it down that we are taking triangle OPQ and triangle OPR. So we are taking triangle OPQ and triangle OPR. Now for the similarity, you need to prove their congruence rule. Okay, so for congruence rule, we are first taking into consideration this angle OQR, which is also 90 degree, and angle ORP, which is also your 90 degree. So first of all, write angle OQP is equals to angle ORP. ORP. What is the reason behind it? Because both of them are 90 degrees. So write each is 90 degree. Next, take into consideration same triangle. What is common between these two triangle? Your line OP. So second, you will write OP is equals to OP. Now what is the reason? It's common. So you will write it's common. And the last one, what you can see from the figure, that OQ is also the radius of the circle, OR is also the radius of the circle. That means this OQ and OR will be equal for triangle OPQ and triangle OPR. So last you will write OQ is equals to OR. What is the reason? Because it is the radii of the same circle. So write the reason, radii of same circle. That means what you have used, it's right angle triangle. This one is your hypotenuse and last one is your side. That means you have used RHS congruency rule to prove the triangle. Therefore, you have proved that triangle OPQ is congruent to triangle OPR by RHS rule. Okay, this much is proved. Now, what you get in your CPCT? What is left out with? We are left out with the two sides. What are these two sides? That PQ is equals to PR. So, for left out, you will write PQ is equals to PR. By what we got it from? We got it from CP. CT, corresponding parts of congruent triangle, which we have already studied in standard 9th. Okay, so this was the thing which we need to prove earlier. See, to prove PQ is equal to PR, and hence we have proved that PQ is equals to PR. I hope you understand, and you can join again for the next session. Thank you so much.